Good morning everyone. Today's topic is about these data structures. Now I will explain about these completed types of data structures and the introduction. Let us see about this introduction of the data structures. That is, data structure is a method of collecting and organizing the large amounts of data more efficiently so that whatever the operations performed on the data, that will be very easy. That the basic operations are insertion, deletion, and updations. Okay, and now we will see the definition and the characteristics of a data structures. These three are the very important characteristics of our data structure. That is, first one is about the correctness. Correctness, that is, the data structure implementation should implement its interface very correctly. And also this, that depends upon the time complexity. That means whatever the operations performed or the running time or an execution time of an operations must be less as possible. That represents the time complexity. The time taken to execute that operations, that should be very less. And also the space complexity. Here the space complexity is nothing but the memory usage of that operations. Here the memory usage of a data structure operations should be as little as possible. These are all the characteristics of a data structure. We'll see the need of our data structure. As if the data is very less, it will be very easy to perform the insertion, deletion, updation, and all the operations should be performed. But if we have a large amounts of data, so these data search and the processing speed and the multiple requests that has been done on these databases or data structures, these are all the three situations where the possible data search. As the data grows, search will become very slower. And also the processor speed. If we have a speed, although being the very fast, the CPU processor, it will falls as a limited data grows. As the data grows, the processing speed will also be decreased. And then multiple requests, multiple users can search the data. If the multiple users search the data simultaneously on the web browser, that also makes some data structures that is very limited. So to solve these three problems, we have been used these three cases, that is worst case, average case, and the best case. In this worst case, if we have the large amounts of data, this will take a maximum time to search the data in our data structure or a database. It will take a maximum time. That means the worst case. And in the average case, the average amount of time it will take to execute that data structure or a processing or whatever the operations that will be performed on our data structure. And the best case that takes a least amount of time to execute that operations. This will be measured by these three cases. That is, worst case, a maximum time it will take to execute that operations, and the average case, average time it will take to execute that operations, and the best case, the least amount of time that will take to execute that operations. If we will measure these data search or a processing speed or the multiple requests using these three cases. Next, we will see about the types of data structures. These data structures are basically divided into two types, that is primitive data structures and the non-primitive data structures. Coming to the primitive data structures, we have that primitive or built-in data structures, that is integer, character, float, and the double. Here, these four primitive data types are built-in data types are predefined library functions or data types that will be built in our compiler or in our program. But coming to in our non-primitive data structures, that will be divided into again two types, that is linear and non-linear. Linear means the data whatever we will be storing in our data structures, that will be in an sequential order. In the sequential order, the data will be stored, and in the non-linear, it won't have any order. In our data structures, while storing our data, it won't have any order. It will be storing in a random format. Coming to our linear data structures, these are again divided into 4 types, that is array, stack, queues and the linked list. Here in that non-linear data structures, these are divided into again 2 types, that is trees and the graphs. Coming to now in our data structures, we won't learn about this primitive data types. We will be learning all about this non-primitive data types, about this linear and the non-linear, and how these 4 types of data structures will store the structure in the memory, and also the trees and the graphs. Now coming to an linear data structure, the first type, it is about the array. Let us see first the definition of an array. Array, it is a data structure which stores the data in an sequential order which consists of a common name with an consecutive memory location. That is the definition of an array, and this will be represented as, let us see the syntax or definition I will write. So, elements are stored in the sequential order with a common name in consecutive memory locations. Okay, that is the definition of an array. Once again, I will repeat. That is, array is a data structure which stores the elements in an sequential order with a common name in an consecutive memory location. And let us see the structure of an array. This will look like this. This is an array, and where we will be storing some data elements here. This is an element, or a value we will be calling it as, and for suppose student is an array name, and array always starts from 0 to n-1 location. That means these are called as indexes. Using these indexes, we can access these array elements. Okay, now here these array element, here with this example, the array indexes are 0, 1, 2, 3 and 4. This size of this array is 5. Okay, this is a size, and the last element, that is in which position, that is n-1th position, the syntax of an array. Syntax of an array, that is data type, array name, and this is a square brackets which represents an array, where we will write the size of an array, and that is equalized to an flower braces with a semicolon here. Now this is a data type, array name. Here within that square brackets we will write an size of an array, how much size we will take, and that is equalized to, this part, it is called as an initialization, and this is a declaration. Either we can do it separately, initialization separate and declaration separate. Either we can do it and then complete the sentence. The both we can at a time, we can initialize and the declaration will be done at a time. Now, let us see with an example how this syntax will be written. That is, for suppose, int is a data type, and array name here I will take as an x, and the size is 5, and I will take a number of elements, that is 10, 1, 15, 25 and 30. These are all the elements that will be stored in an array. This is a data type, and x is an array name, and this is a size, which here these square brackets, that is known as a subscript. Through this, we can identify that is an array. Using this subscript, we can identify this is an array. Now, these are all the elements we will be storing in our array. Let us see with an diagrammatical representation how this data will be stored in an array. X here, as we are storing that elements in this data structure. Now, 1, 2, 3, 4 and 5. These are all that in an sequential order as that elements will be stored, and these are all the 10, 1, 15, 25 and 30. These are all the elements or the values of this array. Values of this array, and here I will take only this integer type as I have represented here integer, so I will take that numbers to store the data in this array. And also here these are all the index numbers. Always this array starts from 0 to n-1th position the element will be stored. And how this will be represented in the memory representation of an array. For the same, in the memory, the data will be stored in an x of 0, the element is 10. And in the x of 1, the element is 1. And in the x of 2, the element is 15. And in the x of 3, the element is 25. And in the x of 4, the element is 30. Here, this way the memory representation of an array, either it may be in an horizontal way or a vertical way. As it is an one-dimensional array, the data will be stored in an horizontal way or in the vertical way. Either the two, the data will be stored in our memory.